Hello everyone, welcome to my channel. In this video we are going to learn about double-ended queue or DQ. Okay. So in the linear queue, the usual practice is for insertion of elements we use one end called rear, and for the deletion of elements we use another end called front. But in the case of doubly-ended queue, we can make use of both the ends, that is both the front and rear. So we are using both the front and rear to perform the insertion and deletion operations, right? That means it is possible to insert the elements by rear as well as by the front. So similarly, it is possible to delete the elements from the front as well as from the rear. So to understand the concept of double-ended queue, let us see the diagram here. Okay, so in the given diagram, in the given queue, so we are having the front and rear parts. So here we can perform the insertion and deletion operations at the front part, as well as we can perform the insertion and deletion operations at the rear part also. Okay, so we can insert at both front and rear positions, and we can delete from both the front and rear positions. So DQ is represented in two ways, that is input restricted double-ended queue and output restricted double-ended queue. Okay. So first we will see the input restricted double-ended queue. Okay. So in this, it means that some restrictions are applied to the insertions. So in input restricted queue, the insertion is applied to one end while the deletion is applicable from both the ends. So here the restriction is only for the insertion, right? So insertion can be done only at one end, whereas the deletion can be done at both the ends. So we can delete the elements from both the ends. So next one is output restricted double-ended queue. So here we can apply the deletion operation at only one end, right? So whereas we can apply the insertion operation at both the ends, right? So where we can apply we can insert the element from both the ends, whereas we can delete the elements only at one end. So that is called as output restricted double-ended queue. Okay. So now let us take a simple example that how the DQ will work. Okay. So I am taking a small array, that is with the elements 1, 2 and 3. So this is the front part and this is the rear part. Okay. So I want to insert the element 40 by the front. I want to insert the element 4 from the front end. Okay, then first we have to shift all the elements to the right side. For example, if you want to insert the element 4 by the front end, then the DQ will be in this format, right? So we have to insert the elements, right? 4, 1, 2, 3. So in order to insert the element 4, we are shifting all the elements to the right side. Okay. And similarly, if you want to insert the element 5, so now then also we have to shift the elements one position to the right, and then you can insert the element 5. Okay, so this is the insertion by the front end. Suppose if you want to perform the deletion operation at the rear end, so we know that how we can perform the insertion at the rear part and deletion at the front part. So here we are seeing how can we insert the data at the front part and how to delete from the rear end. Okay. So if you want to perform the deletion from the rear end, okay, so then you have to consider the array here with elements 5, 4, 1, 2. Okay, so this is the front end and rear end. Okay. Okay, so to delete an element from the rear end, so we have to replace the element which is deleted by the rear with -1. So I am deleting the element 2 here. So it will be replaced by -1. Similarly, the rear is decremented here, and here it will be removed and it is replaced with -1. So if you are going to remove the element at rear end, so you have to replace it with the -1. Okay. So this is how we can apply the deque operation on an array. So we can apply the operations of deque is insertion at the front, deletion from end, insert at rear, deletion from the rear, is the deque full or empty. And other than the insertion and deletion operations, we can also perform the peek operation in the queue. So through the peek operation, we can get the front and the rear element of the deque. So it will display the front element of the deque and rear element of the deque. The deque can be implemented using two data structures, that is the circular array and doubly linked list. So to implement the deque using the circular array, we should know what is a circular array. So if you want to know about the circular array, so please watch my previous videos about the circular queue. So next one is the applications on the deque. So the deque can be used as both the stack and queue. So therefore, we can perform both the redo and undo operations using the deque, and it can be used in the palindrome checker. Means if we read the string from both ends, then the string would be same. So we know the palindrome, right? Madam. So these are, madam is a palindrome, right? If you reverse that same letter also, it will be, the string won't change. So it can be used for the multi-process scheduling or steal algorithm. So these are some of the applications on the deque. So thanks for watching my video. Please do like, share and subscribe to my channel. Thank you. So here we are going to see the operations that we can perform on the deque operation, on the deque data structure using the array. So operations are insertion at rear, deletion at front, insertion at front and deletion at rear. So these are the operations that we can perform on the deque using the array. So first of all, we will see how can we perform the insertion at the rear point. Okay. So how can we perform the insertion at the rear in the queue using the deque operation. So in the case of deque operation, we can perform the insertion and deletion at anywhere. Okay. So anywhere in the queue, we can perform the insertion and deletion operation, right? So it works similar to stack. So in the case of the stack, so we can perform the insertion and deletion operation, right? So we can perform the insertion and deletion operations at one end, right? In the case of the stack. But here in the case of the queue, we are going to perform the insertion at deletion at one end, right? So insertion will be performed at one end and deletion is performed at other end in the normal queue. But here the deque is a combination of both stack and queue. Okay, so in the deque we are going to, in the deck we are going to implement the insertion and deletion operations at both ends. So we are combining the properties of stack and queue, right? So here we are going to, we can insert the data in the at one end. Similarly, we can delete the data at one end, right? So here also we can insert the data at one end, and the same end we can perform the deletion operation, right? So at both ends we can perform the insertion and deletion operation. So we are combining the properties of both the stack and queue here, right? So now we will see how can we perform the insertion at rear. So if you consider the queue here, so how can we perform the insertion at the rear pointer? Okay. So if rear equals to size minus 1, print overflow. That means if the rear is pointing to the last portion of the queue here, then that means all the elements in the, all the spaces in the queue are filled, right? That results in the overflow. Else increment the rear and enter the value into the queue. Okay. So here now initially the front and -1 are the location. right? Front and R are at the location -1. Okay, so we'll consider front and R are at the position -1 here initially. So front comma rear are -1. Okay, so now we will increment the rear pointer and we will insert the data into the queue. Okay, so rear pointer will increase to the value 0, 1, 2 and 3, right? So at 0 it will enter the value and the rear will get incremented here, right? So increment the rear and enter the element. So 2 we are going to element and q of rear equals to element, right? So again increment the rear value. Okay, so increment the rear value, so now it will become 3 and again perform the increment operation on the rear value, so it will become 4. So now rear is pointing to the maximum size -1, that is at the third location, right? So now in this case R is full, right? R is full here. And here the last one, if front equals to -1, make it as front equals to 0. Okay, so this condition will satisfy and front will increment the pointer to the 0th location, will point to the 0th location. Okay, so in this type of scenario, that is R is pointing to the last location. Okay, so then we cannot insert the data into the queue, right? And front equals to -1, this condition will satisfy only once, when first time the front increments from -1 to 0 only, right? So in this way we can perform the insertion operation at the rear pointer. Okay, so now we will see how can we perform the deletion operation here. Okay, so delete at the front. So if front equals to -1, then print as underflow. Okay, so we know that initially the front and rear pointers are pointing to the -1 location. So front and rear will be pointing to the -1 location, right? That means front equals to -1 means there is no elements available in the queue, so it will print underflow. Okay, so else if front equals to rear, okay, front equals to rear means, so if there is only one element in the queue, then so make it as front equals to -1 and rear equals to -1. Okay, else printf deleted element is %d comma q of front. So if there are more than one element available in the queue to perform deletion, then so we are going to apply this formula. So now let us see how can we run this code. Okay, so we are going to increment the, so we are going to insert some values in the queue by incrementing the rear pointer. Okay, so now rear is pointing to the last location. Okay, so now front will get incremented from -1 to 0 here. Okay, so front will point to the 0th location. Okay, so now you are going to check the conditions here, that is if front equals to -1 or not. So front equals to -1 is not satisfied, so we'll go to the else block. So else if front equals to rear, so this is also not satisfied, so we'll go to the else block, next one. So we need to perform the deletion operation. So deleted element is q of front, so we are going to remove the element from the queue and then increment the front pointer. So increment the front pointer to the next location. Okay, so again we are going to execute the same code, and if condition is not satisfied, else if condition is also not satisfied, so we'll go to the else part and perform the deletion operation and increment the front pointer. Okay, so now front is pointing to the second location. Okay, so now again we are going to execute the code, same thing will happen. So we are going to again execute this else block. So now again increment the front pointer. So now front and rear are pointing to the same location, right? So now there is only one element in the queue, right? So if there is only one element in the queue, then in that type of scenario, then this condition will occur, front equals to rear. So we need to delete the element in the queue. So deleted element is the value 4 and make front and rear pointers as -1. So we are going to remove the data in the front pointer and make front and r as -1, rear as -1. Okay, so in this manner, so we can execute this code, deletion at the front. So now we will see how can we perform the insertion at the front. So in the given code, so it is divided into three type of cases: when the queue is full, and when the queue is having only one element, and when the queue is empty, and when the queue is not empty. So these are the three types of cases in the given code. So now let us see how we can perform the insertion operation at the front. Okay, so now let us consider there are some elements in the queue. So insert at front. So if the front value equals to 0, here the front value is equals to 0, then print full. So normally in the case of the rear insertion at rear, we are going to increment the rear and insert the values into the queue. But in the case of the Deque, we have to decrement the front pointer and insert the data into the queue. Okay, so suppose that the front is pointed to the 10th location, then we have to perform the decrement operation, and we have to insert the data at the 9th location. Similarly, here the front is pointing to the 0th location, so there is no memory location here next to it, right? So we cannot perform the insertion operation, and we can consider that the given queue is full, right? So here we are going to decrement the front pointer and insert the data into the queue. Okay, so this is the first case, and the next one is else if front equals to -1. So front equals to -1 means if there is no data in the queue. Okay, so if the queue is empty, then front equals to -1. Okay, so normally in the queue also, so if the front equals to -1 and the rear equals to -1, then the queue is empty. So insertion at front, here front and rear are at the -1 location, so we cannot so in this type of scenario, we have to increment the front and rear pointer. Okay, so we have to increment the front and rear pointer, and we need to insert the data at the front. Okay, so now front and rear are pointing to the -1 location. So now increment the front pointer to the 0th location and insert the data here, that is 1. Okay, so this is when the queue is empty, that is front equals to -1 and rear equals to -1, right? So in this case, so next one is else front decrement the front and queue of front equals to empty, so element, right? So when the queue is not empty, okay, so when the queue is not empty, then this type of case will occur. So here we are having the data 1 and 2. Okay, and front is pointing to the 0th location and rear is pointing to the last location. Okay, so in this type of scenario, so here the front is at the 0th location, so then we have to decrement the value. Sorry, here the front is at the location 1. Okay, so we have to decrement the value and insert the data at the queue of front. Okay, so now we have decremented the value and insert the data into the front, that is the 3. Okay, so in this manner, so we can perform the insertion at the front operation. So if you want to insert an element into the front operation, so we have to decrement the front and insert the data into the front of the queue part. Now we will see how can we perform the deletion operation at the rear end of the queue. Okay, so here if rear equals to -1 and front equals to -1, that means the queue is empty. So in this type of case, we cannot perform the deletion operation in the queue, right? It undergoes underflow, that means there is no element to remove from the queue, right? If the front and rear are equals to -1, then the queue is empty, right? So in this type of case, we cannot perform the deletion operation. So next, else if front equals to rear, that means if there is only one element in the queue. Okay, so here the front and rear are pointing to only one element. Okay, So then we are going to remove the element that by performing the rear equals to minus, we are going to decrement the value from the queue. Okay, so we are going to remove the value from the queue by performing rear equals to -1, right? So then the front and rear value will become -1, right? So then front and rear will become -1. So after removing the element, only one element in the queue, so the front and rear will become automatically -1 because there is no other element in the queue to remove, and the queue will become empty, right, if you remove this element. So that's why front equals to -1 and rear equals to -1. So next, else printf deleted element is %d, q of rear. So this type of case will occur when there is more than one element in the queue. Okay, so when there is more than one element in the queue, this type of case will occur, front and rear. So if you want to perform the deletion at the rear end, so deletion at the rear end, we have to decrement the rear pointer and remove the element from the queue. Similarly, in the insertion at the front end, we have to decrement the front pointer and insert the data into the queue. So then we will remove the data from the queue and we will decrement the rear pointer to the next one, right? Similarly, if you want to decrement this, so you can remove the element and point to the next one. So now front equals to rear, right? So front equals to rear will happen. So now we will go to this condition, and so we are going to remove this element and make the front and rear point to the -1 location. So in this manner we can perform the different operations on the Deque. Thanks for watching my video. Please do like, share and subscribe to my channel. Thank you.